Now we're starting to get more complicated. As I talked about before, adding more predictors means more complications due to more multicollinearity, difficulties in interpretation when you have multicollinear or collinear predictors. And then if you have non-rectilinear relationships and you have categorical relationships, all of the interpretation gets much more difficult. So what I'm going to do is I'm going to talk about what happens when you have nonlinear or non-rectilinear relationships and you have interaction effects. So let's just take a look at what happens when I make a mess of my model. So now I have my categorical model, my first categorical predictor that, remember, is conditioned on x1. And then I have x4, and x4 is my variable that has a curvilinear relationship with y. And so I just want to make sure that everybody knows what that looks like. Come on. And that it is indeed, it's a curvilinear relationship. And that when I start looking at these nonlinear interaction effects, if I haven't corrected for y in some way, then what will happen is I won't have the appropriate effect. And what I should have done is, if I do this, let's see what happens here. Whoops. Oh, right. Because y has 0 values. All right, well, we can square those things later. These interaction effects mean that you have to interpret the non-rectilinear relationships first, and you have to make sure that you correct for them via transforms, because if you don't, then the interactions that they're going to have with the categorical variables are really going to be a mess. So since I created this data, it's easy for me to look at it and understand what the effects are. But the best way to figure out whether we are having some form of errors involved that are propagating through our model with complex interactions and effects is to look at the residuals. And this is why it's going to be so important for everyone to understand what the regression assumptions are that we're going to get to later on in the semester, or actually pretty shortly. But you need to understand what those regression assumptions are. And you also need to look at the residuals, because it's in the residuals where the violation of the assumptions come out. And these residuals will show you that there is some sort of curvilinear relationship anytime you have deviations in your QQ norm plot, particularly if they look like they're swinging to one side, so they come to the lower end of this QQ norm plot up here and here. This is all below the identity line. That when any of these data points are below it here and below it here, and it kind of generally swings up, you can assume that there's going to be some sort of curvilinear relationship. And the only way that we can figure that out or see it directly is you have to plot your data first. And what I recommend doing is plotting data using some sort of matrix scatter plot. And that would be like this. Now, of course, this is getting complicated because when you start looking at these matrix scatter plots and you have lots of variables, you can see here these are my categorical variables, and this is my nested variable. And now what we have is x4 is my curvilinear relationship. So the best way to see x4 and y is if I have y on the x-axis and x4 on the y-axis. So I flip them, you'll see that it has this U shape. And that U shape, not good. We really don't want that U shape, because what that does is that indicates that a line of best fit, a straight line of best fit, isn't going to work very well. Well, think about what happens when we have interactions. If you have a curvilinear relationship that, remember, an interaction is an end, it's a logical end. So if you have a curvilinear relationship between one predictor and the dependent variable, and now you multiply it by, let's say, a categorical variable, well, imagine that that curvilinear relationship now multiplied by a categorical variable, if you're on the low end, and what would happen even if they're nested, if you're on the low end, the part here that's sloping down, and it's related to your nested variable, whoops, here's x4, if you're on the lower end of the range of y, and your categorical variable is really associated with this portion of y, and then your other categorical level is associated with this other portion, well, now you have a situation where you're going to have almost an interaction where that categorical variable really differentiates the slope between x4 and y, but it doesn't take into consideration that x4 has a curvilinear relationship. So again, this is complicated. We're going to get to this in great detail later on in the semester, but this is just a heads up that life can get really complicated.